That was good too. Oh well, whatever. Okay, give me another word besides intermolecular. Say it again.
Intra.
Intra, very good. Bonds. Intra, underline intra a couple times. Molecular forces. That's what a bond is. It is a force, but it's really strong. And it's intra versus down here, we have inter molecular forces of attraction. So these are two separate categories. This is called a bond or a chemical. We could put the word chemical bond in front if we want. You don't have to say the word chemical. So you say bonds, everybody assumes chemical bonds. It's the same thing. So a bond is intramolecular, and forces of attraction are called inter. So intermolecular forces of attraction. That's the category, and here's the category bonds. This is between molecules. That's us shaking hands. This is inside one person. So intra means inside. Inter means in between. You need to memorize that. You need to know that. Not just memorize, be able to explain it. Intra means inside something. Inter would be between. Which one's stronger? Bonds. Strong or stronger than this. These are weak, weaker. There's 4 types of bonds. 4 types. How many lines did you skip? 3? You guys filled up now?
No.
Still got one more? All right. 4 types. So we got 4 types. We have ionic, we have covalent, and there's actually 2 types of covalent. We'll get to that. We have metallic, and we have network solid. Intermolecular forces. How in depth do I want to go with you guys? There's 1, 2, 3. We'll keep it simple. There's 4. 4 types. We'll get to that down the road. I'm not going to list all of them. I don't want to give you too much today. Really, we're going to focus on bonding first. Ionic and covalent, we're going to spend a lot of time on. These 2, hardly any, because they're a lot easier to understand. So we're going to start with these 2 today, and that's what the homework's about. So I know you still have one more line here, so I'm going to get to that in a second. But if you go to your homework now, so it's important now that you understand we're not talking about forces right now. We're going to be talking about bonds. I just need to take a couple minutes to explain the difference, and we're going to draw a little picture here to show that. But again, intra, that's really, really, really strong. That's like what holds me together. It would take a lot of energy to rip my limbs off my body. But here, the shaking of the hands, that's easier to break. You just let go. Okay, so those are a lot weaker. On the homework, all you have to do is look at the type of elements in the compound or molecule. If there is a metal with a non-metal, so up there on the chart, where are metals located? Left. Okay, left of the staircase. Where are non-metals located? To the right. So if you see a compound, we'll do the first one together. If you see a compound with a metal from the left here, with a non-metal from the right, we call that ionic. If you see 2 non-metals together, we call that covalent. That's how you identify on paper if something has ionic bonding or covalent bonding. And again, what the heck does that mean? Well, we're going to learn a little bit more, but basically it's what's holding the individual atoms and molecules together inside them. Not between, but inside one individual molecule. So again, we're going to spend time explaining all that. I don't expect you to fully get it right now. So anyways, look at the first one. You got, what is it, CaCl2? So here's how we do it. You look up Ca, it's over here on the left. Group 2, that's a metal. You find Cl, it's over on the right. It's a non-metal. So, Morgan Heath, if it's a metal with a non-metal, we call that ionic. Very good. Let's do number 2 together just for fun. If you go to number 2, I see, what is it, CO2?
Yeah.
So carbon. Hannah, is carbon a metal or non-metal? Non-metal. Carbon is over on the right. Mike Flowers, oxygen, non-metal or metal?
Non-metal.
Non-metal, oxygen, it's on the right. Two non-metals, what do we call that, Watson? Mike, with me over there, or are you in La La Land? A little bit of both. Well, at least you're honest. Let's get 100% with us here from now on. So a metal with a non-metal, like number 1, that's ionic. Number 2, you have two non-metals. Read the top of the paper there, the homework. Oh, you don't even know we're on the homework. Let's go. Yep, very good. It's a chemical bond. I need to know the type. Do me a second. Do me a second. What? Do me a favor. Take a few seconds. Read the top of the page. Why? Very good. Two nonmetals, it's covalent. So I always tell students, bare minimum. Bare minimum. If you forget everything you learn about ionic and covalent when you get to the regents, at least be able to do what we just did. It's the simplest thing you need to do. If you can look at the metals and nonmetals and remember metal, nonmetals, ionic, that's good. You need to be, that's the very simplest thing you need to know. And then two nonmetals is covalent. Where it gets tricky is if you have a compound like this, NaNO3. This has both types of bonding. Metal, two nonmetals. So look up here. Between the metal and the nonmetal, these two are held together with an ionic bond. These two are held together with a covalent. So you have ionic here, metal, nonmetal, and then you have covalent, nonmetal, nonmetal. So that has both types of bonding. So go to table E, please. Go to table E. The worksheet says if it has a metal with a polyatomic ion, then that is both. So if you go to table E, it has the polyatomic ions right there. So if you see a polyatomic ion in the compound on the homework, that means it has both, just like this, because of what I just explained. It has two nonmetals and a metal. So it has or both types of bonding going on. Okay, so just remember table E exists. We're going to be using that a lot moving forward. That's called polyatomic ions. What's poly mean? Many. So if you look up here, Cl minus is just called an ion, chloride ion. That's one atom. ClO3 minus, that's a polyatomic because it has more than one ion. It has 3 O's and 1 Cl. See, 1 Cl from the chart, that's not poly, that's just mono, right? Mono, but that's not a term. But that's not poly. Poly means more than one. Go to table E. What's that called? What's ClO3 minus called on table E?
Chlorate.
Chlorate, right. It's a chlorate ion. Okay? Find this one. OH minus. What's that called?
Hydroxide.
Hydroxide. PO4 minus 3. What's that called? Phosphate. What's SO3 minus 2? Sulfite. What's SO4 minus 2? Sulfate. So that chart is really useful. Just remember it's there. Okay? Because not only are we learning what bonding is, how it works, how to identify it, but next, how to name these compounds. So if you look at number 7. Courtney, are you all right?
Yeah, I just thought of something.
Okay, so she's over there trying not to smile. She's smirking to herself, trying to be good. I just figured I'd call her out. If you go to number 7, I haven't taught you anything about naming, but this is where we're headed, so I'm just going to do one with you quick, then we're going to start taking notes on ionic and covalent. How would we name number 7? Go ahead and take a stab at it. Don't say it out loud in your head. I think we're not going to fill in that little blank there. We'll move on. How would you name number 7? Okay, thinks to know how to name number 7. Hannah.
Sodium carbonate.
It's Na2Cl3, right?
Yeah.
Yeah. Sodium. Why? Because that's Na, it's sodium. Look this up on table E. It's the carbonate ion. So sodium, carbonate. It's pretty easy. Just take the two names, put it together. That's it. That's how we name these. Except, of course, it's not that easy for all of them. There's some that are harder. I'll get to that later this week. All right. So, write this down. So underneath where you wrote forces, you can put that homework away. Now that you know the difference between intramolecular, which is a bond. Oh, we never drew our picture, I'm sorry. Underneath intermolecular, do this. Draw two water particles. So H2O looks like that. We call it the Mickey Mouse, right? That's kind of what it looks like. That's one water. Put another water molecule kind of like this. Sorry. I think I'm getting a little cold here. One of you people got me sick.
Adam.
Yeah, it's probably one of the basketball players, so the rest of you off the hook. Maybe I'm just sick with the Giants' performance yesterday.
The Cowboys aren't going to get out of the first round.
It's alright. The life is more important than stupid football. Moving on. So, this water here is a molecule, right? There is one molecule. This is another molecule. For those of you who do better, seeing like little drawings or diagrams instead of the actual elements, I'll give you another way to look at it. This is really important, so I'm spending some time on it because if you don't understand the difference here, you're going to be screwed up the next like 3 weeks. Okay, so this and this and that and that, those lines, let's label that. That's a covalent bond. So you could draw this before you wrote that question, hopefully. I'm sorry, it doesn't really matter where you put it, but I wanted this right near where you wrote intermolecular. So that's a covalent bond. Water's covalent. Why? Two nonmetals, H and O, nonmetals. So those are 4 covalent bonds. I'm not going to label each one. Draw a dotted line between one O and one H on opposite molecules. Just do exactly what I'm doing and it makes more sense. Same thing here. Okay, 2 Mickey Mouse here. This line here and that line here, that's like what's holding me together and Olivia. When we were shaking hands, that's the dotted line. So this dotted line right here, that's the intermolecular force. That's weak. This covalent bond, strong. So I'm just going to write that. Covalent bond, we'll say stronger, and we'll say weaker. I use the term stronger and weaker because there are different, it's like a continuum or like a spectrum. However, I think continuum should make sense to you, I hope. There are some forces that are really weak and some forces that are stronger. Then there are some bonds that are weak and some bonds that are stronger, but that's only if you compare them to other bonds or other forces. So I probably confused you. So the point is, these are always weaker than these. I don't care what bond it is, ionic, metallic, covalent, network, solid. It doesn't matter. The bonds are always stronger than any force. So that's what I'm trying to get you to understand. Stronger and weaker. It's much easier for shaking hands to just pull us apart than to rip my arms off my body. It's a really weird analogy, but it's a good one because bonding is what's intra, holding me together, and then inter is between. Am I making this pretty clear, I hope? I hope so. This is a huge misconception. AP kids who get this stuff wrong. Here's what they get wrong. When you boil water, which one is broken? Don't raise your hand. Think. Don't do anything. Just think. Are you breaking covalent bonds when you boil water? Or are you breaking the forces of attraction when you boil water? Which one are you breaking? I've seen this was on an AP test a long time ago, but some kids got it wrong and I just shook my head. Because they should know at that point. Which one's broken when you boil water? Now you can raise your hands. Go ahead, Watson. You're with us now. Right. Prove it. He said we're breaking this when we boil water. You're breaking that. Very good. How can you prove that? You're right. Mike?
Well, because if they break, it's basically evaporating, but it's still water, so it's still water vapor.
Right. So when you break this, all you're doing, liquid water is maybe this close together. When you boil it, the water breaks apart. It's still water. It's still water vapor. It's just in the gas state. They're just not close together. So that's really, 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 really important. Whenever you go through a phase change, you're breaking forces, not bonds. How do you break bonds?
Chemical reaction.
Yeah, you learned this in the beginning of the year. There's two types of changes in the world.
Chemical and physical.
Physical and chemical. Chemical, you break bonds. Physical, you break forces. You didn't know that at the time, but now you do. Now, light bulb should be going off. Oh, everything makes sense. All right. Now, back to this. This is what I'm going to kind of end class with, and then we'll start briefly getting notes on ionic and covalent. But remember that worksheet. So we still got enough time to get some stuff down. But here's the overriding question here. Why we learn about chemical bonding? Why do atoms or ions? I have to put ions in there because ionic uses ions. That's why it's called ionic. Why do things bond? You learned this actually a while ago. You already know the answer to this.
If they lose or gain.
Lose or gain electrons. They could also actually share electrons. Sharing is caring. You can lose, you can gain, you can share. Okay, last night I had some pizza. It's kind of a big deal for me. It was awesome.
Was it like that?
It was organic
Yeah,
pizza,
exactly.
so but it still was so good. It was wood fired. Oh my goodness. Anyways, so I never like sharing food because I eat massive amounts and I'm just selfish with my food. So, but my daughter, okay, she's 13 months. Whenever I eat anything, or my wife eats anything, or anyone in our house is eating something around her, she'll just stare at it, kind of. She kind of does this. She kind of goes. She goes like this. And she goes. She just starts grunting, and I'm like, "Use your words." Whatever. She looks at me like, "What are you talking about?" She's not really talking, obviously, but she wants the food. So why am I talking about this now? How's this relevant to what I just
Because
said?
she gave the dead fish like a look.
No. Yes. Kiss the ring. Anyways. No. She's sharing, right? So there's three things that could happen here. You can share electrons, you can lose, you can gain electrons. So I like to steal everyone's food. I like to eat all the food myself, but of course I share it with my daughter, so I give her like little tiny pieces. But I was making sure I was eating the pizza very quickly so she would get less. She had her own food. Don't look at me like that. She had her own. She had tons of food. Plus my wife was giving her little pieces too. Anyways, I was sharing the food with her. So the concept of sharing is important. There's three ways to bond. You can lose electrons, gain electrons, or share. So anyways, that was a little tangent, sort of related. Explain a little further. So you said they lose or gain electrons. You said something like that, right?
Yeah.
Okay, well, why? If you don't know, that's okay.
I don't know, I just remember that.
That's good.
To become stable.
Yeah. So there's a couple reasons. To become stable. Very good. And in chemistry, to become stable means low energy, which means they don't react anymore. So once bonds are formed, it's kind of, that's it. There's no more bonds being formed. So to become stable, so low energy, that means no more reacting. Oops. No more reacting. And there's one more thing I want to, there are two more things here. What happens when they become stable? You learn this too. Think what Courtney was saying about electrons. Okay, ground state, yep. Something else.
Full balance shell.
Yeah, there you go. Full valence shell. They want a full valence shell. Very good. And in Regents chemistry, there's a phrase for that. Some of the sides got 'em. I'll start it. You guys finish it. Complete octet. Complete octet. So those are the real reasons why any chemical reaction occurs. So if you pour concentrated sulfuric acid on your hand, why you do that, I have no idea. But if you did that, it would be very painful, and the acid would react with your skin and start to eat away at your skin. Why is it doing that? The acid is trying to become stable. The particles in the acid's trying to do this, but it's using your skin to do it. Okay? It's a really weird thing to say, but that's exactly, anytime any reaction ever occurs, this is why. Okay? So the oh yeah, the bell is gonna ring. The concept with those 4 types of bonds right here applies to all of them. So ionic covalent, don't forget to do that, do tomorrow, and that's it.
Yeah, we have a good.
Yeah, we have a quiz next period.
Great.